Start. Okay. Hello everyone, welcome back to our channel Coders Arcade. This is Saurabh again with one more live DSA Java class. Okay, so welcome all, and anyone is new to the channel, as I say every time, please subscribe to our channel and also hit the bell icon so that you get notified about our latest updates. Okay, I will take it slow, I will let everyone join and we'll gradually start, don't worry. And I'll just tell you one thing. Okay, let me also open the same thing in my mobile and just see if you have any comments for us. Okay, and so what I'll do is, okay, so guys, what I said is, yes, till yesterday we have covered our arrays, the introduction to arrays, and we have seen how many types of arrays are there, and also we have seen how we can deal with certain basic concepts of arrays, right? Today we will be starting with what? Introduction to algorithms. Okay, so we will be starting with introduction to algorithms. And what are algorithms actually? We will be learning about them, we will be understanding them, and then we will be going on and we will be trying to understand about searching algorithms today. Fine, what are algorithms? What do you mean by algorithms? The first thing. What are algorithms? Algorithms are something those help us to solve some problems with a certain amount of what? Efficiency. Okay, algorithms are some techniques that help us to solve some problems with certain amount of efficiency. Some algorithms are very fast, some are very slow. We will see all of them one by one. Okay, so yeah, I think some of you have joined. Welcome back again. So as I said, we are live again. This is Wednesday and this is the third live session. This is live session 3. Okay, and I had given the indexing like 0. So this is 0, 1, then this will be the serial number 2. Guys, if anyone is new to the channel and you have not subscribed to our channel, please make sure you subscribe to our channel and also hit the bell icon, because that will help you to get notified about the latest updates, as I keep on telling you. Fine. So as I was telling, today we will be starting with searching algorithms. Okay, searching algos. Fine. So that's why before learning the searching algorithms, yesterday and day before yesterday, we had learnt about arrays, the types. We had talked about 1D array, we had talked about 2D array, we have talked about multi-dimensional arrays, and also especially the jagged ones. Yes, anybody who has come today for the live session for the first time, all the recorded sessions are there in our YouTube channel in a proper playlist. You can go there and check that. Okay, don't worry about that, everything is given there. Fine, and any single doubt, silly doubt, make sure you ask them. Fine. So as I was saying, algorithm is a technique that helps us to solve some kind of problems with efficiency. Okay, the efficiency can be more or less depending on the time taken by that algorithm to complete actually. Okay, so as I said, today we will be starting with searching algos. searching algorithms, and guys, one more thing which is very important, you should know the time complexity. This is not the practical time complexity, this is theoretical time complexity. That's why it is also known as the big O notation. Fine. So, we will be learning that for searching algorithms. Actually, what is this? What are searching algorithms? The criteria is, you will be given an array. Okay, in the array, there will be lots of elements, and you will be given a particular key, that means a particular value, and you will have to search for that value in that particular array. Okay, and if you find, you have to return what? The index, or sometimes the position. Okay, you might be getting confused, right? Index and position, they are two different things. Please remember that. Suppose I have an array 4, 2, 1, 9, 6. Suppose someone says the key value is 9. What is the position of 9 if someone says? Position of 9. The position of 9 is 0, 1, 2, 3, 4. 3 is not the position, mind you. 3 is the index. So, the position is 1, 2, 3, 4, 5. Position is 4. Okay. And what about the index? The index is obviously, it starts from 0, right? So, it is 3. Please make sure you understand these two things very clearly. The position is that number of element. The index is starting from 0 going to that element. Okay. So, it is always n minus 1. Clear? If you write index plus 1, you will get the position. If you write position minus 1, you will get the index. So, this is the relation between these two. I hope you are understanding this, right? So, now in searching algorithms, the criteria is that we have to search for a particular key in the given array. That is why we have learnt about arrays, so that now we can learn about the searching algorithms. And side by side, we will also learn about the time complexity or the time taken by all the searching algorithms. Fine. So, let us start with one of the simplest searching algorithms, which is linear search. Okay. There are 3 searching algorithms that we are going to discuss. The first one is linear search. The second one is binary search. And the third one is what? Recursive binary search. And side by side, you should also know the time complexity. So, we will be discussing that, but just for you I am writing out, this is big O of n, this is big O of log n, this one also it is big O of log n only. Okay. Now, do not focus on this guys, we will understand about this practically, do not worry. Let us start with the first one, that is linear search. Okay. Anything you are not understanding, please comment, okay. I will be waiting for your comment, do not worry about that. Fine. So, the first one that we will be learning is linear search algo. So, you will be given an array, this is your array. Two, 9, 8, 6, 1, 4, 3. Random values. You can have negative numbers, it does not matter. You can have any element in the array. Now, indices 0, 1, 2, 3, 4, 5, 6. These are the indices. This is your array. Int ARR is equal to this, not curly brackets, I have just written the block shape diagram. Fine. Linear search, you have to find a key. Obviously, it is an integer array, so the key will also be an integer. Int key equal to, say suppose I am saying 4 for example. What does linear search say? Linear search says that it is one of the simplest searching algorithms where we traverse the entire array from index number 0 till index number 6, and if we find this particular key, what do you return from the function? The method or the function, what do you return? You return that particular index. Okay, you return that particular index. Suppose now I have 4 here. Okay, we start traversing from index number 0. Here this doesn't match this, so we keep moving. They don't match, right? We keep moving. How do you keep moving? It's very simple, by using a looping statement. Make sense? We use a looping statement and keep checking. The code can be like this: if ARR of I is equal to the key, I goes from here. See, the I value keeps on going like this. I is here, then I is here, then I is here, then I is here, because it will be a simple for loop. For I is equal to 0 to what? We don't go till the last element, we will go till 6, right? 0, 1, 2, 3, 4, 5, 6. This for loop, we have this condition. I am just writing you the pseudo code, not the whole code. Okay, we will write the code, don't worry. If our array of I is equal to the key, this does not match actually. Right now it is not matching. Here 6 doesn't match with 4. Next 1 doesn't match. I is incrementing. I is going from 0, 1, 2, 3, 4 doesn't match. Next index. Now guys, ARR of I is equal to the key. This matches. We have actually found the key, which is 4. See, here I got the match. What do you return? I said I need to return the index. What is the index number? The index number is 5. Make sense? How do you return? Which variable is actually representing the index here? The I variable. The I variable. Right now it is here. So simple, return that particular index. Done. That's all. That is all about linear search. Understood? It's very simple and the code is also very simple. Now the point is, what if I have some key which is not available in the array? There might be some key which is not available in the array, right? In that case, what do you do? So suppose excuse me, I have a key which is say 22. This key obviously is not present in the array. Make sense? So what will happen? It will traverse. Here also it will traverse. After that, it will see that, oh, I did not find the key. Now what should I return? The return type of this linear search function will be a integer, right? So in case of programming, we can return -1. So in the else block, we can return -1. That means it says that we did not find the key. Make sense? That is how simple linear search is. Now the most important thing, time complexity. Try to understand, okay? I have a for loop which is going from 0 to a particular value n-1. Okay, 0 to a particular value n-1. So I have to travel from here till here. Sometimes what happens, the key can be the first element only. Okay, try to understand what I am saying. In certain cases, the key can be at the first element only. That can be the best case. Okay, the best case where therefore the time complexity will be at one go only we found it, right? The best case time complexity is big O of 1. We found it at one step only. But sometimes the key can be at the end of the array. I have to traverse the whole lot of array elements, right, one by one till the nth element. So, the worst case time complexity is big O of n. Make sense? One for loop going from the beginning to the end of the array, we are traversing all the elements. So, the time complexity is O of n. Clear? This is how it is about linear search. Now, let us do one thing. Let us write down the code so that we can verify whether we have understood or not. Okay? I will go back to my editor and let us say here we have learnt about arrays, right. So, I will just say new Java package called algorithms. In algorithms, let me say a new package called searching, and inside searching let us create a new Java class called linear search algo. Fine. So, this is my Java class, and what I will do, I will just maximize the size so that you can also view it. Fine. Right now there are no comments from anyone. So, I feel everything is working fine and everyone is understanding what we are doing. Now, here is my main function. Okay. In the main function, what I will do, I will create an array. Guys, I am not taking any input from the user. If you want, you can do that using the scanner class, does not matter. Okay. I will just take the array is equal to let us write down say 2, 4, 1, 3, 6, 5, 9, 7. Fine. This is my array. Now, I will create a function linear search, and which will do what? It will take the array and the key that you are searching, Say suppose for the time being I am writing the key is 3. Okay. Now, I have not yet implemented or written this function, right, or the method. Let us do it. So, here rather than creating an object, I will directly create like this. I will say static int linear search. Okay. And here what I will do, I will just paste this here, print this because I need to print it, and here also do like this. So, yep, linear search, this takes an array and it takes what? It takes the key, and yep, what was the first step? You guys have to tell me what was the first step. The first step was to traverse the array and keep on searching, right. So, for I equal to 0, I less than the whole length of the array. So, I can say ARR dot length I plus plus. Simple condition, if our ARR of I is equal to the key, what do you return? Return that particular index. Okay. If it is equal to the key, return the index. But this for loop is done and you actually did not find, what do you return? -1. That is, I did not find the key in that particular array. This is a very simple algo, and that's it. That's it about the code, nothing else. Let's do one thing. Let's run this. So, I have written 3 here, right? What is the index of 3? 0, 1, 2, 3 actually. So, rather than getting confused, let's write something like what 9 here, the key is 9. So tell me the index. 0 1 2 3 4 5 6, 6 index I have 9. Let me run this and see what we get. Can you see here, guys? At 6th index we actually found it. Rather than that, we can also do something like this. This is returning an integer data type, right? I can simply say int index is equal to, store that value here. After that, what I will do, I will say s out key found at index plus index, the index value that we have. Okay. So, here key also we can write like this. Okay, that is fine, absolutely fine. Now, see the output. Key found at index 6, absolutely yes, the index is actually there at fine. Now, as I said, what was happening when we had something invalid? It was returning -1, right? Let us see which cases you will get this. Suppose I am writing a key called 91. Obviously, 91 is not present in my array. It should return -1. Key found at index -1. Clear? This is how simple linear search is. It's very, very simple. I hope you have understood this. Guys, anybody who is new to the channel, if you are liking the content, please comment that you are liking the content and also motivate us by subscribing to our channel and hitting the bell icon. Okay, fine. If you have understood linear search and if you have liked this, please comment. Okay, and now after this, now I guess we can go to the next searching algorithm, which is binary search. Okay, and one more thing before we conclude this particular algo, I will just say one more thing. In case of linear search, there is no need for any sorted array. The array can be in any order, no sorted array required. Okay, in case of linear search, there is no need for any sorted array. It can be in any order, it can be ascending, descending, mixed order, it does not really matter, because it will just search for the key and then it will return the index if it is available, or else it will just say that the key is not found. Guys, you can tweak with the code that I have written here, and you can just write the code by taking from the user the input, and you can do so many things. But the most important thing is to understand the algo. That's all. That is the most important thing. And my motto will be to make you understand the algo, not write taking the scanner class, taking input for the array. That you can do on your own, because if you are learning DSA, the base part of writing Java code is very simple. You should know that already, right? So I hope you have understood linear search properly. Now let's go to the next one, which is binary search. Very, very important concept, guys, and I'm telling you, 80 to 90% of placement drive questions can be solved using binary search. So make sure you understand that properly. Okay. So we will move on to the next one, which is binary search. Fine, let's go. So as I said, there is no prerequisite, so no sorted array required for linear search. Let's go to the next one, which is binary search. Why binary search? Because linear search takes a lot of time. O of n time complexity is linear time complexity, but still it takes a lot of time, because if the number is at the end of the array, if the element is at the end of the array, it will take O of n time. Okay, so we need to reduce the time complexity. So for that, welcome to binary search. This is one of the best algorithms for placement drives, for competitive coding. You can solve so many questions using binary search. Okay, so let's try to understand this binary search in a very easy and efficient manner. Fine, but prerequisite for learning binary search. the array should be sorted. You need a sorted array to apply binary search. Fine. Let's understand this. Here is my array. Okay. So, indexes 0, 1, 2, 3, 4, 5, 6, 7 and same thing. Let's take some numbers here. I am taking 2, 4, 5, 8, 9, 11, 13 and 15. Okay. Sorted array, guys, please remember, sorted array, otherwise binary search will not be applicable. Okay. So, now what is the principle of binary search? The principle of binary search is that each iteration the array is divided into halves. Okay. The array is divided into halves. How do you do it? You do it something like this. You take a start point. The start is the beginning of the array. You take a end point, which is the end of the array, and then you find something called the mid value to break it down into two parts. Okay. So, mid value will be start plus end divided by 2. Fine. And I will take scenarios so that you can understand this efficiently. Don't worry. Now, formula. Start is 0, 0th index, and the end is what? 7. Divided by 2. So, this is actually 7 by 2. What does it give you? It gives you integer division, guys, 3. So, this is our mid value, this particular value. Okay. We got the mid as 3. Now, let us take scenarios now. I will take key is equal to say 13. 13 is the key. Now, this is my mid, remember. 3 is the mid, you found out here. Now, we have to do some checks. The first check is if our ARR of mid, that particular value, is equal to the key. What is mid here? Mid is the index, right? This is the index. Is ARR of 3? Is ARR of 3 equal to the key? That means is 8 equal to 13? No. So, this will be skipped. Otherwise, we will go to the else if part. Else if there will be two conditions. One will be it will be less than or it will be greater than. Okay. So, if our ARR of mid is, say suppose, greater than the key, or let us take less than only for the time being, because we have taken less than, right. So, let us take less than, otherwise you will not understand. If ARR of mid is less than the key, then what happens? Tell me what happens? Yep. Just let us write down so that you can understand. What is ARR of mid? 8. Is 8 less than 13? Now the case becomes interesting. See here what happens. 8 is really less than 13, right? That means we are searching for a number which is 13, but which is not on this part of the array. So, this part of the array does not have that particular number. Where is it residing? It is not on the left hand side, it is on the right hand side of the array. Make sense? It is at the end of the array. So now what should be done? It is invalid to search it here, right? Why should I search? My number is greater than what I have here. The mid value does not have that number. That is the benefit of having a sorted array. If it is sorted, all the elements on this side, actually all the elements on this side of the mid will be less than the key always. So it is unnecessary to search on this part. Make sense? That's why what should we do when this condition is prevailing? I should set this start here so that I can do this operation on this side. How do you set this here? What is this value? Mid. So start will become mid plus 1. Make sense? So now let's make the change and try to understand here. See this. Start is what now? Latest start. What is the latest start value? The start value becomes mid plus 1 means how much? 3 plus 1, it becomes 4. Now again calculate the mid value. Mid equal to start plus end by 2. See this. What is the start value? 4. 4 plus end is what? 7 by 2. That means how much? Let me write a dash here. 11 by 2. Okay. 2 5s are 10. This is 5. We got the new mid. Now again repeat this. This is what? Our new mid. Check this condition. Is ARR of mid equal to the key? Yes or no? No. Again what will you do? The same thing will happen. Is it less? Yes, it is less. Actually 11 is the value. 11 is less than 13. What do you again do? Same thing. This part of the array is not required now. Understanding? That is how it is working then. So your start will again become, this is the mid now, mid plus 1, that is, this is the start. So this becomes start, this becomes end. Okay. Now see this. Now formula will be start plus n by 2 again. So start becomes 6 and n becomes 7. 6 plus 7 by 2. Now see this. 6 plus 7, 13 by 2. What is 13 by 2? 2 6 are 12, right? 6 is the new mid. Now check again, okay, mid. Check this condition. Is ARR of mid equal to key? See this. This is the new mid now. Is 13 equal to 13? Write down. Is 13 equal to 13? Yes. We got our key. Now what should you do? Here, return which index is representing that particular index. It is the mid value. So here I will return the mid. That's all. Got it? That's simple. Understood? Now let's take one more type. 2, 4, 5, 8, 9, 11, 13, 15. Okay. So what I will do? 2, 4, 5, 8, 9, 11, 13, 15. 2, 4, 5, 8, 9, 11, 13 and 15. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Let's write down the indexes. 0, 1, 2, 3, 4, 5, 6, 7. Let's do the other way around. We know the first condition. If ARR of mid is equal to the key, we return what? Return the mid, right? Else if ARR of mid is less than the key, that means what happens here? We are on this side, the key is on that side. Start should be shifted. Start equal to mid plus 1. That we had done right now. What is the last part? Let's see that now. Then only we will understand that. Suppose my key is now say 5. This is the key. Okay. So I am writing not like this. Let's not make the diagram ugly like this. So rather than that, I will say my key equal to 5. This is the key that I am searching for. Now calculate the mid. Mid is again same formula, start plus n by 2. Okay. So how much? This is the start, this is the end. So 0 plus 7 by 2. This is again 7 by 2, that is 2 3s are 6. Now check the same thing. Obviously the first one will be false, right? First one will be false, not valid, because what is the error of mid? 8. 8 is not equal to 5. 8 is not equal to 5. Not valid. Go to the else block. Is ARR of mid less than the key? Is 8 less than 5? No. Then comes the last block. Actually 8 is greater than 5, right? This is true. So now it will go to the else part. Else what? Tell me. If I did not find now see this. This part is, this part, or let me write down like this. This part of my array does not have the key. Unnecessarily, why will I search this side? So where should I go? That case I was shifting to the right hand side, this side, I will shift to the left hand side. How do you do that? This is my mid value. So my end value will come here, so that I can only search this part of the array. Make sense? How will you write that? End is equal to mid minus 1. Got it? Do it. Start and end. End you got a new value. So write down the formula. Start plus n by 2. That is, start is 0 only. End is how much? See here. You will understand. How much? 2 by 2. 0 plus 2 by 2. So how much did you get? 2 by 2 is 1. Now do the check again. This index, what are you searching for? You are searching for 5, okay, remember that. So now try to understand, then only you will understand, otherwise you will get confused. Check this condition. Is ARR of mid equal to key? 4 equal to 5? No, but 4 is less than 5. If it is less than, this condition is true, right? What do? You go, you shift the start mid plus 1. Now see this. Start and end are coinciding. Okay? Start and end are coinciding at the same point. Okay? Start is 2, end is 2. So, start plus n by 2. Do it. 2 plus 2 by 2. This is 4 by 2. How much? This becomes 2. The new mid is 2. Now do this. Is ARR of 2 equal to 5? That means is 5 equal to 5? Is it working? Just check. 5 equal to 5. We got, right? We got the answer. So return the mid. Here we have already done that. So we will get this index. This index is having the answer. Got it? If the array key, if the key is on this side, shift the start mid plus 1. If the key is on this side, the left side, shift the end mid minus 1. That's all about the logic. Fine. Let's try to write down the code so that you can understand this. So this is the binary search algo, right? So main function, and here I will say int ARR. Let's take our example only that we have written here, 2 4 5 8 9 11 13 15, okay, is equal to, I will say 2 4 5 8 9 11 13 15. And now let's do one thing. I'll say int index is equal to, call the binary search function and pass our array and the key. let's take the key to be 13 in the beginning, just like we did earlier, and let's do one thing, index 1 I will say this, and one more time that we did, int index 2 is equal to, again I will call this binary search function only. We have not written this, guys, just make sure you don't get confused. And this one, what did I take here? I had taken 5, right? So let's take 5 here. Okay, and now what I will do is, let's print both of them, s out, index 1 and s out index 2. Now we have not implemented them yet, we will implement them now. Okay, let's write down the code. Okay, you can put it on top also. So I'll say static int binary search, which takes the array, and what else? It will take the key. That is very important. Okay, now everything is working fine. Okay, now let's write down the algo. What was the start value? Tell me in the beginning. The start value is 0 and the end value is, what is this? This is actually the length minus 1, right? I will say int start is equal to 0 index, int end is equal to array dot length minus 1, n minus 1, whatever value we have. Okay, now let's calculate the mid. Mid equal to, what was the formula? Start plus end divided by 2. Okay, now guys, there is one thing that you have to remember. Just see here. In any case, if you try to understand this, it will be very important for you to understand and remember this. Okay, please make sure you understand and remember this. One very important thing. This is start, this is end, this is say 2, 5, 8, doesn't matter. If there is only one element, the start and the end can coincide, right? Index 0, that is possible. This is possible, absolutely fine. This is 0 index 1, 2. But in any scenario, can the start go beyond the end? End is here, can the start go beyond the end? This is not possible. Worst case, they can be equal, or it will always be less. So in the loop, I will write something like this. The loop should be while start is less than equal to end. It cannot be greater. Okay, then I will be doing the calculation. So while start is less than equal to end, what are the conditions that we are checking? If our ARR of mid is equal to the key, what did you do? Return that mid value, right? The first thing. Else, what were you doing? Tell me. If ARR of mid is less than the key, the mid value is less than the key, we should go to the right hand side. How do you write that? Start is equal to mid plus 1. Okay, else block, if the start is mid plus 1, obviously the other way around, it will be end equal to mid minus 1. Okay, but you have to update the mid value, because every time the mid value gets changing, right? So just copy this value here and paste it here after this line. Update the mid value. Make sense? Till here everything is fine. So this will work for normal cases where you are finding the element index, but sometimes you will not find the index. At that time you have to return minus 1. That means element not found. You are returning a negative index when you are not finding the element. Okay, fine. So in this case, key 13, what is the index? 0, 1, 2, 3, 4, 5, 6. 6 index, key 5 0 1 2 second index. Let's run this and see if it is actually working or not. See guys, 6 and 2, they are absolutely working fine. Hope you have understood them. Fine, all okay, everything fine. I hope everything is okay and you have understood the algo. As simple as that. Now comes the most important thing. What is the time complexity? How do you calculate the time complexity? Code, you have very simply understood that. Okay, let's do one thing also. Let's write one more thing. I'll copy the same thing and say paste this. This time I will say index 3, and if I'll say array 50, 50 is not there, right? So I'll say s out. This time I will say index 3. What should be the index value here? It should be what? Negative index -1, right? Let's run this and check. See guys, you're getting -1. The code is working absolutely fine, no problem at all, right? You guys can do one thing. You guys can take input from the user for the size, for the array elements, and then you can write down this code, no problem at all. But most important thing is you have to understand the algorithm behind this. Okay? Hope everything is fine and you are understanding that. Please like and share our videos more and more if you feel that you are really having some fun learning the algorithms. Okay? And I bet you, if you understand the way the algo works, it will be very simple, like bread and butter, to write down the code. Got it? So now let's go and focus on the time complexity part. Guys, one moment, the battery has to be changed. I'll be right back. Okay, yeah, I'm back. So what I was talking about is time complexity of binary search. Try to understand this, very simple. I have the array. This array, what is the size of this array in the beginning? 0 to some n values, n elements are there, right? The size is actually n. But as soon as you find the mid, the array is broken down, right? The array gets broken down into 2 halves, maybe equal halves or may not be, doesn't matter. Say suppose I am saying it is broken down into n by 2 and n by 2. After that, again it will be broken down, more halves, n by 4, n by 4, n by 4, n by 4. Got it? It is again broken down like this, and then again it will be broken down like this. This becomes n by 8, n by 8, n by 8, this is also n by 8, this is also n by 8, and keeps on going, right? Understanding? So now see this and try to analyze this. N becomes divided to n by 2, n by 2, n by 2 becomes divided to n by 4, n by 4, n by 4, n by 4, then n by 8, 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 and one more and one more. So you can see that n by 2 to the power, this is actually 2 power, see this is 2 power 1, this is 2 power 2, right? 2 power 1, this is 2 power 2, this is 2 power 3. Make sense? Therefore, it is 2 power some value k, correct? And k, this k is equal to 0, 1, not 0, it will be not from 0, it will be from, initially it is 0 only because it is here. N by, if I write here, this is 2 power 0, that is n by 1, nothing. So, k equal to 1, 0, 1, 2, 3, dot, 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 it keeps on going. Now, we got this, right? How do you represent this? You represent this in log of n times. How do you write it? You can say this k is constant, right? You say log of 2 to the base n is equal to k. This constant can be represented like this in logarithmic equation. Okay. Finally, what do you derive? You derive that this k or the time complexity is log of n, logarithmic time. So, this is comparatively very fast than linear search. Okay. It is very faster than linear search, because you can see every iteration the array is divided into half. We are eliminating lots of separate values. Okay. This is how this is represented, and you also can write big O of log of n. This is the time complexity of binary search. Clear? But guys, one more very important thing. I hope you have understood this derivation, how this is working. Clear? One more very important thing that you should know, because you might be writing or you might be attempting lead code, coding ninjas or code chef interview questions. At that time, you should remember this very important thing. Please remember this, and you will thank me for this. If not today, you will thank me one day. I am challenging you. The mid value is found by start plus end by 2. Correct? The start plus end by 2. Say suppose what is the range of the integers? These are integers, right? The max integer value is 2 power 31 minus 1. The minimum integer value is minus of 2 power 31. Correct? This is the min integer value. This is the max integer value. Somehow, say suppose we have a very large array and we are trying to find the sum, start and end, and calculating the mid. What happens, you know? Suppose there is a very big value max plus max and we are writing by 2. What happens? This is also one max value. This is also one max value. It will go out of range, right? Out of bounds. In that case, what is actually done? What is actually done? We don't write the same formula, because this will work for simple algorithms and simple coding questions. It doesn't matter at all. But in some cases, this can happen. This will go out of bounds, OOP. Okay? And your test cases might fail when you are trying to solve lead code or coding ninjas questions, or maybe geeks for geeks questions. It might fail. So, what is the best way to write it? The same formula is written like this. Mid is equal to start plus end minus start divided by 2. This is the optimal formula for mid. Please remember this. You write this anywhere, it is 100% certain to work, because reason. Take LCM, here I have 1, the LCM is 2. So, this will become 2s plus E minus S. Okay, 2s plus E minus S. Ultimately, it becomes what? You can see 2s minus S becomes S only. So ultimately the formula is start plus n by 2 only ultimately, but just to avoid this overload we are writing the formula like this. So this is the optimal formula for finding the mid in an array. Start plus n minus start by 2. So please remember this. This might help you out in some interview questions or maybe some face-to-face interview. Why? To write the formula like this. So I have written like this: mid equal to start plus end minus start divided by 2. Ultimately you are deriving the same thing only. Let us verify this. Let us write it here so that you can see this. What I will say is something like this: say start plus, in the bracket I will write end minus start by 2. Okay. Same thing I will copy and I will update this here, paste. Okay. No other changes. Let us verify if this is working or not and we are getting the same output or not. See, whatever output we already had, we are getting the same things. So guys, please remember this formula: mid equal to start plus end minus start divided by 2. So I hope you have also understood and learnt binary search in a very good way. Okay. So any doubts, anything that you have, you can ask in the comment section. Now, how do you apply recursion to learn about recursive binary search? Okay, let's do it. Let's try to understand. Guys, what are the parameters that are changing actually? What are the parameters that are actually changing? Tell me. The start is changing, mid plus 1. The end is changing, mid minus 1. Correct. Nothing else is changing. These things are the things that are changing, right? So let us take the function like this using recursion. Okay, let us write down now. Try to understand. Okay, the complexity will be same, O of n only, O of log n only, not other than that. But let us write down the code so that you can understand this. I am trying to use recursion here. Okay, so I will say right click. Just a moment, please. I will say binary search recursion. Fine. This is my class and say I am saying static int recursive binary search. And what are the parameters that are changing? I said I need the array, then I need what? I need the start value, I need the end value because that is changing every time, and I need the key. Now just try to understand what is happening. What was the base case or the edge case? The start cannot be greater than the end, right? So what I will do is I will just write down like this: if our start value is so greater than the end, I will return -1. That means I actually did not find. When the start value goes beyond the array, I did not find that particular key. So I am just returning -1. I am handling it here itself, right? This is also one way of writing. Otherwise, okay, let us write down the conditions now. We do not even need a looping statement now. See the magic. I will say if our, the conditions you already know, right? If ARR of mid, we have to calculate the mid. So let us calculate the mid. Int mid is equal to, I will write that formula only, start plus end minus start divided by 2. Fine, we have written this. Now let us try to write down properly. If our mid is equal to the key, what were you doing? We were returning the mid value only. Make sense? Else if if our ARR of mid is less than the key, if the mid value is less than the key is actually to the right hand side. So, what does shift? What shifts? The start shifts, right? So, I will return, I will call this recursively like this. How? I will pass the array only, the start will change. So, start will become mid plus 1 and end will be end only, does not change, and the key. Got it? Understood? Otherwise, what happens? Else, the end will change. Here the start is changing, otherwise the end will change. So, I will say return recursive binary search array, the start will not change, the end will be mid plus 1, end will be mid minus 1, right, mid minus 1, and the key will be key only. And yes, that's all guys, that's all about this one, and hope you have understood this. And because this is a recursive function, automatically it will handle everything. Let's try to see if it is working. So, after this function, what I will do, I will go to the main function and say, I will take the array, let me copy it from here, this is my array, and yep, let me copy this, paste it here, and then let us say int index 1 is equal to, call the recursive binary search, pass my array, and the start value and the end value you have to pass from here, right. The start is 0, the end is what? Tell me, what is the end? The length of the array minus 1, ARR dot length minus 1, and you have to give the key value. Let us suppose first one is 13 only, that we already had. Okay, this one 13 only, same thing. I will copy the whole thing, paste, this time let us say it is index 2. What was the key? The key was 5, right? And let us take invalid one, index 3 is equal to recursive binary search, pass the array, the start is 0 and the dot length minus 1, and the key is say 90, which is not available in the array. Now, after that let us print index 1, index 2, index 3. See guys, how I have applied recursion here, try to understand. What I did, if the start value goes beyond the end, return minus 1, otherwise calculate the mid value and then check like this. Okay, because it is recursive, it will again calculate and it will keep on checking like this, correct? And the time complexity will be same, O of log n only. Let us verify by running this, okay, if it is working or not. See, 6, 2 and minus 1, same values we are getting. But isn't it cool? We don't even need a looping statement. We are doing it using recursion. This is the recursive approach and the algo. Now, I hope binary search is absolutely clear for you and you have understood inch perfect everything about it. If you have any doubts, the comment section is all yours. Please make sure you comment all your doubts, okay? And if you really like the video, if you really understood the 3 searching algorithms, linear search, binary search and recursive binary search, please tell your comments in the comment section, okay? And this much for today. I'll be winding up. So, this is Saurabh signing off for today. See you tomorrow in the next live session.